Good afternoon to you all. Today's lesson is on algebraic expression, and this is for the junior high school students. Even though the senior high school students also do this topic, but this is basically for the junior high school students. Under algebraic expression, we use letters, symbols, numbers to represent it. And always some symbols are constant, like a symbol like pi. This is constant, it can't be changed, because we know pi is equal to 22 over 7, or 3.142. So algebraic expression, we use numbers, letters, and also symbols. So take note. So now, I want us to know how we form algebraic expressions using certain statements. If I write something like 7 times a number, so you let the number be x, you choose a variable, let the number be x. You can choose any variable apart from O, so take note. So 7 times a number, this is the same as 7x. So I'm showing you how we write or form algebraic expressions. 2 less than a number is x minus 2. If they give you 5 more than a number, is the same as y plus 5. Half a number is the same as 1 over 2x, and this is the same as x over 2. Twice a number added to 2, and the result is multiplied by 4. So twice a number added to 2. So twice a number becomes twice a number. Twice a number, it becomes 2x. The variable is x. This is added to 2. So it becomes 2 plus 2x. And they are saying the result is multiplied by 4. So this whole thing is multiplied by 4. So you can simplify this. 4 times 2 is 8. 4 times 2x is 8x. You see, I'm getting algebraic expression. This time, I have my number and variable. So they can give you certain statements to form algebraic expression. Take note. So for you to appreciate algebraic expression, you should note this, because it's very, very important if you don't know how to write expression for these statements. Now, let's move on to open and close statements. Open and close statements. So a statement is said to be open if it contains one or more variables. And for closed statement, it doesn't contain any variable. Take note. I repeat, an open statement contains one or more variable, but closed statement contains no variable. If an equation is neither true nor false, the equation is an open statement. If an equation is neither true nor false, the equation is an open statement. But for closed statement, it gives a true value. So I can ask you to identify open and closed statements, and we know close statement gives a true value, but open statement is neither true nor false. Now, 1. She is a Ghanaian. So we have many Ghanaians. Who is a Ghanaian? Akwesi can be a Ghanaian. Emina can be a Ghanaian. Now, we use a pronoun here. And this one, you see, this pronoun is for female. It can be Adwa, Emina, Akosia, Abeta. We don't know the person. But they wrote she is a Ghanaian. So it makes it an open statement. 2. Yao is handsome. You see, this time is specific. Who is handsome? Yao. So this makes it a closed statement. But if this was to be the boy is handsome, the boy is handsome, it makes it an open statement. 3. They have given you this. They have given you this. And you have been asked to identify whether it is an open and closed statement. And this is an open statement, because it's neither true nor false. 4. The number is an even. We have many even numbers. 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number, 12 too. The number is an even number. This is not specific, so it's an open statement. But if they said 2 is an even number, this time it makes it a closed statement. Take note. 2 is an even number. It makes it a closed statement because it is giving us the true value. But now it's saying the number is an even number. 5. December has 31 days. It's true. December has 31 days. So this is a closed statement. Closed statement. There are 4 days in a week. No, we have 7 days. So it makes it an open statement, because this is a false statement. They have given you this statement: S is greater than 1 but less than 1. 6. They have been specific. They are specific here. So it's a closed statement. Closed statement. Because you can simply list this one. You see, S is greater than 1 but less than 6. So it's 2, 3, 4, 5. So it's a closed statement. This is different from this. This one, it will be difficult for you to list this. 8. Kwesi is a brilliant student. Who is a brilliant student? Kwesi. Who is a brilliant student? Kwesi. They are being specific here. So it makes it a closed statement. So it's not difficult. So always know the difference between open and closed statements. Closed statements give a true value that it contains no variable. But for open statements, it contains one or more variables. And it gives a false statement, like it's neither true nor false. For open statements, it's neither true nor false. So take note. We are now on addition of algebraic expressions. And for addition of algebraic expressions, we have like terms and unlike terms. If we say something is a like term, like this marker, you see it's a like term because they are all black markers. But if I take this duster and marker, it's not a like term because this is a duster and this is a marker. You can't what? Add it. You can't combine cats with dogs. Take note, but we combine dogs with dogs and cats with cats. That's a like term. So we have A plus A. You see, this is a like term. So we can add like terms. So A plus A, we know is 2A, because coefficient of A is what? 1. But we can't add A plus B. It's not possible. A plus B can't be added. So this is unlike term. But this is like term. You can add like term. So they can give you power of letters. Power. When I was treating indices, I taught you power. So a cube plus 2a cube. You see, this and this, they are what? Like terms. But if they gave you a squared plus 2a cube, you see, it's not a like term, because we have a square and this is a cube. They are different. This is square and this is cube, so you can't what? Add it. So this is unlike 10. And this, once you add it, it becomes 3a cube. It makes it like 10. So I believe we all know what a like term is. And that would make addition of algebraic expressions very simple. So I can give you, write the following in its simplest form. 1. P plus P plus P plus P plus P. 2. X plus 2x plus x plus 3x. 3. 4x plus m plus 2x plus 3m. 4. 2p squared plus 3p squared plus 4p cubed plus p plus p squared. So I can ask you to write the following in its simplest form. So if you are given something like this, it's very simple. So write the following in its simplest form. So you add it. And as I said, the coefficient of p is 1. So this plus this plus this plus this plus this is 5p. 2. X plus 2x plus x plus 3x. So this plus this is 3x. 4 is 7x. 3. So this one, you group it. I want you to write it in its simplest form. So it's 4x plus 2x plus m plus 3m. Because this is a like term and this 2 is a like term. So 4x plus 2x is what? 6x plus m plus 3m is 4m. So that is the answer. 4. Now we have 2p squared plus 3p squared plus 4p cubed plus p plus p squared. So this, and this like terms. So it's 2p squared plus, so it's 2p squared plus 3p squared plus p squared plus 4p cubed plus p. You can add the like terms. This plus this is 5p squared plus p squared is 6p squared plus 4p cubed plus p. That's the answer. So that's for addition of algebraic expressions. So let's move on to subtraction of algebraic expressions. Subtraction of algebraic expressions. same thing as the addition, just that this time they have introduced the subtraction sign. Here too we apply like terms and unlike terms. So if I give you 3a minus a is 3a minus 1a, 6p cubed minus 2p cubed minus 2p squared minus p squared. So you subtract the like terms. Subtract like terms. 6p cubed minus 2p cubed. You see this and this is a like term. At times they can mix them up and they will ask you to arrange. Once you don't arrange, you can't solve it. So this one, you are fortunate they have arranged it for you. So this minus this is 4p cubed. And this, from this we have negative 3p squared. So the third one, 10qr squared minus 4q squared r minus 5qr squared minus 3q squared r. So this one, you see they have mixed them up because this and this is not like 10. We have q squared and we have to check the number that matches this or the expression. So you see this and this, they are like 10. So it's 10q r squared minus 5q r squared, and these two they are like 10 minus 4q squared r minus 3q squared r. So this minus this we have 5q r squared minus this we have 7q squared r. So I have simplified this expression. So now I'm going to combine addition and subtraction of algebraic expression. Once we know like term and unlike term, simplify the following. 1. 4p plus 2p plus 3p squared minus 2p. 2. 5qr minus 2qn plus 2qr squared plus 3qr plus 4qr squared. 3. 10n cubed plus 2n squared minus n plus 4n squared minus 4n cubed. 4. 8ac plus 3ab minus ac plus 2ab plus 4. You have been asked to simplify this expression. So I have now combined addition and subtraction of algebraic expression. Question 1. 4p plus 2p plus 3p squared minus 2p. So which of the following are like terms? This, and this. They are like terms. So you group it. So it's 4p plus 2p. First of all, you arrange it minus 2p plus 3p squared. 4p plus 2p is 6p minus 2p is 4p plus 3p squared. That's our answer. Question 2. We have 5qr minus 2qn plus 2qr squared plus 3qr plus 4qr squared. So you arrange it. Now, this and this, they are like terms. So 5qr plus 3qr. These two, they are like terms. Plus 2qr squared plus 4qr squared. The last number with variable s minus 2qm. Now, this plus this is 8qr plus this is 6qr squared minus 2qm. So always for addition and subtraction, you arrange the like terms and also the unlike term. Take note. But if you are fortunate for them to arrange it for you, it becomes simple. Question 3. 10m cubed plus 2m squared minus m plus 4m squared minus 4m cubed. Now, this and this, they are like terms. This and this two are like terms. This means you can add and subtract. So 10m cubed minus 4m cubed. You take note because this negative is for this 4m cubed. Take note. Plus 2m squared plus 4m squared minus m. This minus this is 6m cubed. This plus this. So 2m squared plus 4m squared is what? 6m squared minus m. So it's not difficult. This minus this is 6m cubed. This plus this is 6m squared minus m. 4. We have this, and you have been asked to simplify. So AC, this and this, they are like 10, this and this like 10, but this is constant. So 8AC minus AC plus 3AB plus 2AB plus 4. This from this is 7AC because the coefficient of AC is 1, but we don't write. Plus 3AB plus 2AB is 5AB plus 4. So let me rewrite it well. So this is 5AB plus 4. That's the answer. So we are moving on to multiplication and division of algebraic expression. So for multiplication and division of algebraic expression, you should take note of some key concepts. A times B, so note the following. A times B is the same as AB. A times A is the same as A squared. 2A times A is the same as 2A squared. 2A times B is 2AB. 2B times 2A is 4AB. A times B times C is ABC. So I can give you, write the following in its simplest form. 1. M times M times M times M. 2. A times B times A times A times B. 3. 3B times B times B times B. 4. A squared times A times A. So you have been asked to write the following in its simplest form. Solution. 1. This times this times this times this. You see, if you were supposed to add m plus m plus m plus m, it becomes 4m because the coefficient for m is 1. Here too, the coefficient for m is what? 1. But in maths, we don't write. We do not write the coefficient for a variable because 1 times the variable is equal to the variable. So m times m times m times m, we have m4. So the first one is m raised to the power 4. This times B times A times A times B. So you rearrange it A times A times A times B times B. This becomes A power 3 times B power 2. 3. This times this times this times this. How many P's? Is 4. So 3P to the power 4. 4. A squared times A times A. So this is additional to it, so it becomes A power 4. So these are your answers. If you are asked to write the following in its simplest form, once you know this, multiplication and division of algebraic expression becomes simple. So I have given you these questions to simplify, and you also apply indices for multiplication and division of algebraic expression. So 1, 4p times 8p squared. You take the numbers 4 times 8 times p times p squared. So 4 times 8 is what? 32. Times p squared is p cubed. So it becomes 32p cubed. 2. We have 7s squared. Y raised to the power 4 times 2s cubed. Y 2. So 7 times 2. We have s squared times s cubed. Y 4 times y 2. 7 times 2 is what? 14. So x, you add the powers, because if the bases are the same, you add the powers. Y4 plus 2. Then you have 14x, 2 plus 3 is what? 5. Y, 4 plus 2 is what? 6. So that is the answer. 14x5, y6. 3. 4x5 over 4s cubed. Even though they have written it like this, but you should represent it this way so that it becomes simple. So what is the common factor that can divide 4 and 4? You can use 4, 2. So 4 goes here 1, 4 goes here 3. So you have 3x5 over s cubed. And this becomes 3x5 minus 3. Since the bases are the same and they are dividing, subtract the powers. So 3x squared. So 4. The fourth one. 21x7 over 3x4. 3 goes here 1, 3 goes here 7. So we have 7x7 over x4. So it becomes 7x7 minus 4. So this is 7s cubed. So it's not difficult. You still apply indices here. The last one. 16a cubed b over 2ab. 2 goes here 1, 2 goes here 8. So it's 8a cubed b over ab. So we have this will cancel this. This 8a cubed minus 1. So we have 8a squared. Removing brackets and the algebraic expression. To remove brackets, we use the distributive property. Distributive property. So if I give you A, B plus C, always we use the number outside or the letter outside to multiply the numbers or letters in the brackets. Take note. So if I give you A bracket B plus C, A times B is what? AB plus A times C is AC. So you see I have expanded it. So 2C plus D. It becomes 2 times C plus 2 times D. So 2 times C is 2C plus 2 times D is 2D. 3. 4 minus C. 3 times 4 is 4 minus 3 times C, 3C. So you take note of this subtraction. Negative 3 P plus C. So So negative 3 times p. So this negative 3 will affect the p and also c. So it becomes negative 3 times p plus negative 3 times c. So negative 3 times p is negative 3p plus negative 3 times c is negative 3c. So you see, removing bracket is not difficult. So question 1. So we have 2, 3 plus x. 2 times 3 is 6 plus 2 times x is 2x. Always use the number outside to multiply the terms in the bracket. So this is our answer. 2, 3a, a plus 4ab minus b. So 3a times a. So it becomes 3a times a plus 3a times 4ab times minus 3a times b. So 3a times a is 3a squared plus 3a times 4ab is 12a squared b, because a is multiplied itself 2 times, and this time this is negative 3ab. So I've expanded it or removed bracket. So 12b minus bracket 5 plus 2b bracket close minus 7. There is 1 here, but we don't write. So 12b, negative times 5 is negative 5. Negative times 2b is negative 2b minus 7. So you can subtract. This minus this is what? 10b. This minus this is negative 12. So take note, because you can simplify. You can simplify this. But this one, you see, you can't simplify because there are no like terms. That's why I didn't simplify it. Take note. But this one, you can simplify because 12b and this b is a like term, and this is a like term. Question 4. I have given you 4. So let me solve the 4th question here. So 4. So 4x plus 1 plus 2x plus 1. So 4 times x is 4x plus 4 plus 2 times 2x is 4x plus 2. So you have something like this. You add your like 10. So you group it 4x plus 4x plus 4 plus 2. So this plus this is 8x. Plus this is what? 6. So this is your answer. Let's move on to the last one. The last question. You see, they are giving you 2 different brackets. But always, if you are given something like this, you first solve for the bracket in the middle first. So this comes first, and this is the second bracket. So 2a, a plus 6b, plus 4 times 2a is 8a. Minus this times this, 4b. So you have 2a, so a plus 6b plus 8a minus 4b. So 2a, let's simplify. Do we have any like term? Yes, this and this like term. So a plus 8a plus 6b minus 4b. So 2a, this plus this, 9a, plus this minus this, 2b. So this times this is 18a squared, plus this times this is 4ab. That's our answer. Multiplication and division of algebraic fractions. We know if I give you a over b, this is the numerator and this is denominator. And always for multiplication of fraction, we multiply the numerators and also the denominators. If I give you a over b times a times c over d, it is a times c. You multiply the numerators and the denominators. So a times c is ac over b times d, bd. So if there is a common factor that can divide, you divide it. If I give you x over y divided by p over q, For you to change this division to multiplication, you must find the reciprocal of the second fraction. So it becomes x over y times q over p. Reciprocal simply means you are turning this upside down, and that will make this division to be changed to multiplication. So understand this concept once I introduce multiplication and division of algebraic fractions. So question 1. We know 9 goes here 1, 9 goes here 2, 5 goes here 1, 5 goes here 3. You see, I've used common factors to divide. So we have s squared y over ab times 2a squared b cubed over 3xy. We have something like this now. Once you have something like this, it becomes s squared y. You will multiply this numerator by numerator and this denominator by denominator. After that, you simplify it. So it becomes this times 2a squared b cubed over ab times 3xy. So you have s squared y. Now let me start with this number. 2a squared b cubed. You add this to it. X squared y over 3xy ab. Now you simplify this one. So it becomes, we have 2 times a times a. You can expand or you can use indices. So I'll solve both approaches. So 2 times a times b times b times b. Now I'm expanding it. Times x times y over 3 times x times y times a times b. So we have x and this will cancel this. This will cancel this. A will cancel a and b will cancel b. So we have 2 times a times b times b times x over 3, because this, we have cancelled all of them. So we have 2 times a is 2a times b times b times x. So it becomes 2a b squared x over 3. That's your answer. 2a b squared x over 3. Or you can apply indices. Let me apply indices. So we have 2 over 3. Now, you see, for indices, if you have the same basis, you subtract the powers once they are divided. So we have a squared minus 1. This is 1. B cubed minus 1. S squared minus 1. And y 1 minus 1. We have 2 over 3a. Because 2 minus 1 is a raised to the power 1, but it's the same as a. So b squared x y 0, and y raised to the power 0 is 1. So I'll simplify it. So you have so it becomes 2 over 3 ab squared x y raised to the power 0 is 1. So you have 2 over 3 ab squared x, because x times 1 is x. So it's 2ab squared x over 3. So you see, we are getting the same answer if you compare. Whether you use the indices or expansion approach, it's not difficult. Question 2. I'm just going to use the expansion method. And to use the expansion method, you multiply the numerators and denominators. After that, you expand. So u5 v2 times 2st over 3s squared t times 5u cubed then 5. So let's expand. U is 5 times u times u times u times u times v times v times 2 times s times t over 3 times s because s is 2 times t times 5 times u times u times u times v times v times v times v times v. But I will advise my students, I will advise them to use the indices method approach. If you don't take care and you don't know what you are doing, this one will confuse you. So now, let's cancel out u. This u will cancel this, this will cancel this, this will cancel this. So I have finished cancelling my u. Let's move on to v. This will cancel this, this will cancel this. I'm done with v. Let me move on to s. This cancel this. T to this cancel this. So we have u here. So it's u times u times 2. So we have u times 2 over 3 times s times 5. 3 times s times 5 times v times v times v. U times u is u squared times 2. You have 2u squared over this times this is 15. S times v times v times v. You have s v cubed. So this is your answer. If you don't want any problem, please use the indices approach. I won't advise my students to use this one. That's why question 1 I saw for both approaches. So the third question I will use the indices approach. But this is also another approach that my students can also try their hands on. So now I am going to use the indices approach to solve this one. This time I won't expand. So now you have been given something like this. You ask yourself, can you get a common factor that can cancel out? 4 goes here 1, 4 goes here 5. 5 goes here 1, 5 goes here 10. So you have E7 F cubed over M10 F2 times 10 M15N over 5G6F. You multiply the numerators and the denominators. So it's E7 F3 times 10 M15N over M10 F squared times 5G6F. So this is what you do. Now, you see, you have reached this stage. And to solve this one, it becomes 10 M15N G7F3 over 5G6F M10F squared. 5 goes here 1, 5 goes here 2. So since the bases are the same and they are dividing, you subtract the powers, indices. So you have 2M15 minus 10. So M, we don't have M here, so right. What about E? E is here, so E7 minus 6. You have F here, F3 minus 2. So you have 2M. 15 minus 10 is 5. N. So G, 7 minus 6 is 1. F, 3 minus 2 is 1. So you have 2N5. N, G, F. Because E raised the power 1 is E, F raised the power 1 is F. So this is our answer for the last question. So you see the indices approach. Once you know the principle and rules for indices, it becomes very simple It's not difficult. So if I gave you something like this, 10b squared c over 5b c squared divided by 15, you have here to be x cubed y over 2x squared y 5. So you see, I've given here as division, but this time you will change this one to multiplication, and to change this one, you find the reciprocal of this. You find the reciprocal for that. So it becomes 10b squared c over 5b c squared times 2s squared y 5 over 15s cubed y. So once you have found the reciprocal, the division sign will change to multiplication. So once it has been changed to multiplication, you multiply the numerators and you multiply the denominators too. So 5 goes here 2, 5 goes here 3. So you have 2b squared c times 2s squared by 5 over 5b c squared times 3s cubed y. So it's not difficult. Always, if there is a division, you find the reciprocal. Take note. And once you find the reciprocal, the division sign will change to multiplication. After that, you multiply the numerators and also the denominators. So now you have 2 times 2 is what? 4. So you have b squared c s squared y 5 over 5 times 3 is 15. So b c squared s cubed y, and you apply indices. So you have 4 over 15. So you have b squared minus 1, because once the bases are the same and they are divided, you subtract the powers. So c 1 minus 2 s, you have 2 minus 3 y 5 minus 1. So 4 over 15, b2 minus 1 is b1, c 1 minus 2 is negative 1, x 2 minus 3 is negative 1, y 5 minus 1 is 4. So this is the same as 4 over 15 b. So c power negative 1, x power negative 1, and y power 4. That's our answer. So now, for addition and subtraction of algebraic fraction, you find the LCM. That's the least common multiple. Always fractions, we find LCM. So 1, a minus b over 3 plus 3a over 2. So what is the LCM? LCM is 6. 3 goes into 6, 2. So 2. So you put this into bracket a minus b plus 2 goes into 6, 3. 3 times 3a is 9a. So 2 times a, you expand this. That's why I first taught you removing brackets. You see, it follows. So 2 times a is 2a minus 2 times b, 2b, plus 9a over 6. So you can simplify. You can group like terms. You have 2a plus 9a minus 2b over 6. So 2a plus 9a is 11a minus 2b over 6. That's the answer for question 1. So this is question 1. Question 1. Let's solve question 2. Question 2. 5 over 6r minus 3 over 4r. So they can combine addition and subtraction for you of algebraic fraction. So LCM is what? 12r, because a letter is being attached. Because the least common multiple for 6 and 4 is 12, but attach this r. So 12r 6 r goes into 12r, 2, because this r will cancel it. So 2 times 5 is 10, minus this goes here 3, 3 times 3 is 9. So you have 1 over 12r. This is your answer. The last question. Question 3. So question 3. 3a plus 5b over 4 plus a plus b over 8. What is the LCM? LCM here is 8. So 8. 4 goes into 8, how many? 2. So you put these terms in brackets. Plus 5b plus 8 goes into 8, 1. So 1 times this is the same as a plus b. So you remove the bracket. 2 times 3a is 6a plus 2 times 5b is 10b plus a plus b over 8. So you can group like terms. You have 6a plus a plus 10b plus b over 8. 6a plus a, you have 7a plus 11b over 8. So this is the answer. The coefficient of a is 1 and b is 1. In maths, we don't write. So that's our answer. So I'm done with addition and subtraction of algebraic fraction. So we are on multiplication of two binomials. And when we talk of binomials, it's an expression of two terms. Binomials is an expression of two terms. So if I give you a plus b and c plus d, these are binomials. Take note, it's an expression of two terms. Binomials is an expression of two terms. We always simplify binomials using the distributive property. Take note. So if I give you a plus b and c plus d, and you are asked to simplify this, you use this a to multiply this c plus d, this b will also multiply the c plus d. So it becomes a c plus d plus b c plus d. This means the numbers in the brackets, all of them will multiply the brackets, that's the second bracket. So a times c is ac plus a times d, ad, plus b times c is bc plus b times d is bd. So you see, I've used the distributive property to simplify this one. So if I give you x plus 3, y plus 4, x, y plus 4 plus 3, y plus 4. So x times y is xy plus x times 4, 4x, plus 3 times y is 3y plus 4. So this is our answer. So this one, if they give you something like this, it's not difficult. You see, if I give you 2 squares, it's the same as 2 multiply itself 2 times. So this one 2 is 5y minus 2. 5y minus 2. So it becomes 5y minus 2 minus 2, 5y minus 2. So 5y times 5y is 25y squared. This times this is negative 10y. So this times this becomes negative 10y. This times this is plus 4. So you see this and this, they are like terms. So it becomes 25y squared. This, it becomes negative 20y plus 4. So this is your answer. So under multiplication of two binomials, you should take note of this. So this is the same as this square minus. So it becomes 2 times a times b, 2ab. And this square becomes plus b squared. But know how to work this. This is the same as a squared plus 2 times a times b is 2ab, and this plus b squared. This is the same as a squared minus b squared, difference of 2 squares. This is difference of two squares. So take note of this and know how to work this. If I ask you to work this, a plus b squared, it's not difficult. It becomes a plus b, a plus b. So a plus b plus b, a plus b. So a times a is a squared plus a times b, ab plus ab plus b squared. So you have a squared, this and this you can add, plus 2ab plus b squared. You see, we are getting this. We are getting this. So it's not difficult. So always know this under multiplication of two binomials. So you should note it carefully. So under algebraic expressions, you can be given certain expressions to write it as a single fraction. And if you are given something like this, you see this is subtraction. So definitely you find LCM. And the LCM, you take the denominators, but you put it in brackets, x minus 1. So this is how you do it, x minus 1. This goes here, this will cancel this, so it's left with x minus 1. This one, 2, this will cancel this, so it's left with 2x plus 1. So it becomes 3x minus 3 minus 2 times x, 2x minus 2 over x plus 1, x minus 1. So you can also remove these brackets. So it becomes 3x minus 3. 3x minus 3 minus 2x minus 2 over x out, x minus 1 plus 1, x minus 1. So you can group like terms on top. It becomes 3x minus 2x minus 3 minus 2 over x times x is x squared minus x plus x minus 1. This will cancel this. So 3x minus 2x is x minus 5 over x squared minus 1. So this is our answer. So this lesson, I divided it into two. And this is the end of the first part. The second part will be on factorization. Factorization. The second part will be on factorization. And that will be the last part under algebraic expression. So our next lesson, I will treat this heading under algebraic expression. Please and please, if you haven't subscribed, you can use this time to subscribe. Thank you, and I believe you have really enjoyed my lesson on algebraic expression.